Hello, welcome to our series Manage Well and Get Preserved about digital preservation of research data. This time we are going to talk about metadata schemas. They are a structured way to document information about data objects. Using specific vocabularies or ontologies when you describe data makes the data more discoverable and reusable. Rich and interoperable metadata helps you make sure your data is understood correctly. Metadata elements are pieces of information like title and creator. When the elements are grouped and designed for a specific purpose, they are called metadata schemas. Many different schemas are used as standards across disciplines and data repositories. Metadata schemas that are developed and maintained by organizations such as the Dublin Core Metadata Initiative are called metadata standards. To ensure findability, accessibility, interoperability, and reusability of your digital resources, the metadata needs to be understood now and in the future. Standards are well documented and are a safe choice. Using standards makes your data more fair. In the digital context and open science, the need for documentation is more extensive compared to research publication a century ago. Today, the research process and outputs are complex and diverse, and the requirements on metadata are higher.
Traditionally, authorship for publications has been relevant and closely linked to copyright. This is not sufficient in a digital context. There are many different ways to contribute to research process and regarding research data. Both for documentation and credit purposes, it is valuable to make distinctions and describe different kinds of input and efforts. The traditional way of just adding long lists of authors or contributors doesn't serve reproducibility or fair communication about merit. As such, there have been efforts made, for example the credit taxonomy, to catch all the relevant inputs regarding research datasets. Besides this, there are roles that are especially relevant for research data, as data needs stewardship and metadata maintenance over time, even after publishing it and further when archiving the datasets. There might be a need to manage access or take decisions about future migrations. Also, there are many different kinds of restrictions and availability. Data can be read, downloaded, copied, edited, deleted, and so on. The aim is of course to make all this as well documented and machine actionable as possible. Still, very often, reuse of data also requires contacting the providers and creators anyway for more information or invitations to cooperate. Someone then has to keep the metadata up to date. Usually a good rule of thumb is the less restrictions and the more open license, the easier the management. When done well, open data is beneficial both for the data creator and the community as a whole. If you are affiliated with a Finnish research institutions, you are entitled to use the Fairdata.fi services free of charge. The Fairdata services have integrated support for various contributors, one example being the data curator. This contributor is the one who keeps metadata up to date and is the one to get in touch with if you have any questions about the dataset. This is why the contributor should always be kept up to date. This is an example of how a metadata schema and element often need further specification and documentation in each implementation and context. In Finland, we have quite extensive recommendations for how restrictions and the grounds for restrictions should be expressed. The aim of this is to enable machine accessibility and make management over time efficient. For instance, a clear machine-readable expression about the legal basis for copyright restrictions or other restrictions based on a certain legal ground combined with timestamping can make it easier to keep access and other rights management up to date automatically. As is traditional for publications, embargoes are also present in datasets as well. This means that before a certain embargo date, only the metadata of a given dataset is publicly available. The data, that is the files or folders included in the dataset, is not available to download. After the embargo date has gone, the data is made downloadable again. These embargoes may be something that is requested from the publisher of dataset. Data comes in many forms and shapes, and this is reflected by the vast amount of different data formats. As modern research utilizes huge amount of different tools, infrastructures, and software to produce data, the metadata standard has to be able to handle different file formats without hiccups. This means, for example, handling of MIME types in correct format and conveying this information to metadata in a machine-actionable way. In addition, research datasets typically consist of a set of files that are dependent of each other when utilizing the data, for example raw binary files, their processing code and documentation files. This shifts the focus away from individual files and file formats to a set of files with different roles constituting to the research dataset. As research datasets vary in size and form, there is usually something discipline-based extra information for dataset. For example, datasets in geography almost always include some kind of spatial information, that is coordinates, places, shapes, and boxes. To accompany these extras, the metadata model needs to be flexible enough to properly contain this information and convey it to users. Research datasets are often a complex set of data objects, and it is important not to only document the object itself, but also its relations to other objects, like previous or later versions. A rich metadata schema enables making these kinds of relations and structures machine-readable and clear. Here you can see some DataCite relation types. The data provenance or lineage describes the history of the DataCite, its origin and sources, as well as the events and processes it has gone through. As a research dataset always contains several data points, the structure of the dataset itself can and should also be made accessible for machines to render and query when feasible. In any case, it is important to acknowledge and mitigate the risks of misunderstanding data and have solutions for data citation and versioning at hand. Also, technical obsoleteness is a potential risk. All this creates requirements for the metadata. These types of metadata are often called structural and technical metadata. The Fairdata services use their own data model, which is interoperable with various metadata standards and is based on DCAT. This is done via mapping the data model in such way that the documentation of equivalent metadata elements from other standards is maintained and updated. This interoperability is supported further by utilizing machine-actionable endpoints that support the standard protocols of REST and OIPMH. This allows other services and also humans to access and reuse the metadata inside Fairdata services as they see fit.
What are then the most common metadata schemas for research data? There are thousands of them. In practice, researchers often depend on the repositories and services that are available to them. Many services use the Dublin core metadata set of metadata elements with some additional properties and classes designed to facilitate resource discovery. Many services and communities have created own application profiles or extensions to Dublin core. One of the more widely used is Darwin core. The Dublin core metadata initiative today maintains a set of DCMI terms that can be used as the base for modern semantic solutions. The DataCite metadata schema is linked to the DataCite DOI. It is a set of metadata elements that is developed for research data. It's domain agnostic and compatible with research information management systems and supports discoverability well. The Data Documentation Initiative is an international standard that has its origin in in describing the data produced in surveys and other observational methods in the social, behavioral, economic, and health sciences. Its structure supports machine actionability on a deeper level, and there are efforts to develop a DDI cross-domain integration, DDI-CDI. The Finnish Social Science Data Archive uses DDI. These were just a few examples of the many metadata schemas. Metadata can be shared and copied into different discovery services like DataCite, Etsin, EU.B2Find, or OpenAIRE, and the persistent identifiers will always take the user back to the original source where the data is. To achieve this findability across services, we often need to create mappings and crosswalks from specific metadata schemas to more generic metadata models. The DCAT ontology is a metamodel that supports fair sharing of metadata. The fair data point is an implementation model for exposing all relevant information for machines. Now, where can you find information about metadata schemas? Information about metadata schemas and services can be found in registries like fairsharing.org and re3data.org. Fair sharing has rich information about metadata in services. There are also several attempts to create registries to support interoperability on different levels. In Finland, application profiles can be published in the interoperability workbench at tietomallit.suomi.fi. This service supports semantic interoperability and machine actionability. The data model, with its classes, associations, and attributes, can be mapped to metadata elements. Researchers rarely create metadata services themselves. If you do, you should preferably use existing metadata elements and schemas as far as possible. Own extensions and application profiles should be documented, preferably in machine-readable format. The application profile also explains in detail how the different elements are used. This often requires extra explanation about how the metadata is created and should be interpreted. Thank you for watching. In this video, we explained some of the basics regarding metadata and research data management. Research often requires rich metadata to document the datasets so that they can be managed and reused in a sustainable way. Next time, we will talk about what metadata is especially relevant for preservation. See you then.